Hello everyone, welcome once again to Learn Mathematics. Myself Rekha Chhabra, your maths teacher. Please don't forget to like, share and subscribe this channel and keep learning mathematics through my YouTube videos. So today's topic is chapter number 10, Vector Algebra, in which we are going to discuss what basically a vector means, what is the difference between a vector and a scalar quantity. Then we will see different types of vectors, vector laws of addition, components of a vector, direction cosines and direction ratios, scalar or dot product. Then we will talk about projection of a vector and finally vector or cross product. So let's start. If I talk about quantities, so in our daily life, we generally come across two types of quantities, physical quantities, namely scalar and vectors. A quantity that has magnitude only is known as a scalar. For example, height. Height is only height. We don't have any kind of direction in that. Plus, we have length, time, temperature, so many other quantities also. If I talk about vector quantity, then it has magnitude as well as direction. If a quantity has these things, magnitude as well as direction, it is called as vector. For example, force, velocity, acceleration, and many more. A directed line, now we talk about the representation of vector. A directed line is called a vector. We have studied a ray in our junior classes, right? So that is also the symbol of vector. A directed line segment with initial point A and terminal point B is the vector denoted by AB, like this. If I give it a name as AB, so this AB is a vector and that's how I'm going to write it. And the magnitude of AB is denoted by these two lines, modulus and like this. This will be the magnitude, the length of this vector. We usually denote a vector by a single letter with an arrow on it, and its magnitude is denoted by this letter only. We write down the magnitude like this also. Now, let's talk about different types of vectors. We have different types of vectors like unit vector, equal vectors, co-initial, collinear, negative of a vector, zero vector, or free vectors. So, let's study these vectors one by one. First of all, let's talk about zero or null vector. A vector whose initial and terminal points coincide is called a zero vector and is denoted like this 0, and on the top we will have this vector symbol. So the magnitude, as the name says, zero vector, so definitely the magnitude of this zero vector is 0. Then we have unit vector, very important vector. Unit vector, a vector A is called a unit vector if its magnitude is 1. If the magnitude is 1, then we call it as unit vector and it is denoted by A cap. We write unit vector like this, A cap, B cap, or anything like R cap. Then next we have co-initial vector. As the name says, co-initial. Co-initial means whose initial point is same. Two or more vectors having the same initial point are called co-initial vectors. In this figure, OA and OB, they both are having same initial point. So these two vectors are co-initial vectors. Then next we have collinear vectors. Collinear vectors means having the same or the parallel supports are known as collinear vectors. Like in this figure, AB, BC or AC all are collinear vector. If I make this vector, vector A is this, vector B is this. So then also these vectors are collinear. Collinear you can simply take the meaning as parallel vectors, right? So this A and B are collinear vectors. If A is here and B is in this direction, then also these two vectors are collinear. Then we have equal vectors. Two vectors A and B are said to be equal if they have same magnitude and the same direction, regardless of the position of their initial points. So they are called as equal vectors like this. So they should have same direction, and they should have same magnitude, right? So they will be called as equal vectors. Then we have negative of a vector. A vector having the same magnitude as that of a given vector A and the direction opposite the of A, right? Same magnitude with opposite direction is called the negative of A, and it is denoted by minus A vector. For example, you can look at this figure. If this is vector B in this direction, so in the opposite direction, this vector with the same magnitude will be called as minus B vector. If this is B, so this is minus B. Then we have triangle law of addition of two vectors. So in a triangle OAB, if OA and AB, this OA this side and AB this side, represent vector A and vector B respectively, then OB represents A plus B. It means their sum, or we call it as resultant. So the resultant of vector A and B will be this vector OB, right? Please take care of the direction. If we are here at the initial point, we are going in this direction O to A. Then from this terminal point, we are going to point B in this direction. Then the resultant will be in this direction from O to B, right? So we have to take care of this thing, direction. So this is known as triangle law of addition of vectors. We have one more law for addition, which is called as parallelogram law. What this law says, in a parallelogram OABC, if OA and AB represent A and B respectively, then OB represents vector A plus B or their resultant. Or simply you can understand like this: if we can represent two vectors as the two adjacent sides of a parallelogram, like this A and this B, and now if you complete the parallelogram, so the resultant of this A and B will be this leading diagonal or the longer diagonal. This will be A plus B. Just because it is a parallelogram, so definitely this side is also going to be vector B. So this is somewhat like triangle law only, and this is called as parallelogram law of addition of vectors. The next topic we have components of a vector. Let O be the origin and P be any point in the space, right? If we have a 3D plane like this, X, Y and Z. Now P is any point in this plane. Let I cap, j cap, k cap be the unit vectors. We have just studied unit vectors, and now students, one more thing: I cap is always in the direction of x-axis, j cap always in the direction of y-axis, and k cap a unit vector in the direction of z-axis. These are three unit vectors along x-axis, y-axis and z-axis respectively. Let the position vector of P be R. This is origin and this is point P. So this is, let's say, this is R. So this R position vector OP will be xi plus yj cap plus zk cap, and this is called as component form. And in this component form there are three components: x, y and z. They are called as scalar components, and when we add directions with them, I cap, j cap and z cap, then they become vector components. And what will be the magnitude of this vector r? It will be under root x square plus y square plus z square. Now we have direction ratios and direction cosines of a vector. Consider a vector r, which is a I cap plus b j cap plus c k cap. Right? Now the numbers a, b and c, these three numbers are called direction ratios of r. And direction cosines, basically what do we mean by direction cosines? Let's take a point P. This is any point in the space, and now if we make a position vector from origin, then definitely x, y and z, all three x's are going to make certain angles with this position vector. Right? Let's call those angles as alpha, beta and gamma. Right? These three angles are called direction angles. And when we take cos with them, cos alpha, cos beta and cos gamma, they are known as direction cosines. And we normally represent these three direction cosines with L, M and N. And the direction cosines of R, this is the formula A upon magnitude of that position vector, b upon magnitude of that position vector, and same here with c, where a, b, c are these three scalar numbers. If L, M, N are direction cosines of a vector, then we always have, this is very important result, then we always have L square plus M square plus N square is equal to 1. If A and B are 2 points in the space, then direction ratios of AB will be, we just have to subtract their x coordinates y and z, means x2 minus x1, y2 minus y1 and z2 minus z1, and we will get direction ratios. And direction cosines, how would we get direction cosines of this vector AB? It will be x2 minus x1 upon r, y2 minus y1 upon r and z2 minus z1 upon r. And r will be definitely, do you remember distance formula? Yes, it will be that only, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, because this AB vector is the vector which is joining 2 points A and B. Be 2 points in the space, and then direction ratios of AB means we have 2 points A and B, and then we have a vector AB which is joining these 2 points. Then definitely direction ratios will be x2 minus x1, y2 minus y1 and z2 minus z1. And direction cosines, when we divide these things, x2 minus x1 upon r, y2 minus y1 upon r and z2 minus z1 upon r and r, that's how we find distance formula. Then next we have, let's talk about the product. We have four basic operations: addition, subtraction, multiplication and division. So for addition, we have studied two laws: triangle law and parallelogram law. Then we have product, multiplication. Here we have two types of multiplication. One is dot product and the other is cross product. So what is the difference here? We call it as scalar product or dot product of two vectors. Let A and B be two vectors and let theta be the angle between them. Definitely, let's say we have these two vectors. Let's say this is vector A and this is vector B, and here we have angle theta. Then the scalar or the dot product of A and B is denoted by A dot B. As the name says, dot product, so A dot B. And it is defined as magnitude of A into magnitude of B into cos theta. Or we can simply write down as AB cos theta. Why we call it as dot product? What is the difference in dot and cross product? When we multiply two vectors, sometime we get a scalar quantity and sometime we get a vector quantity, right? So when we get scalar quantity, we call it as dot product, and when we get vector quantity, we call it as cross product. So this is the basic difference. Now the angle between two vectors, we can find the angle from this formula only. Cos theta will be equal to A dot B upon magnitude of A into magnitude of B, or simply we can say theta is equal to cos inverse this thing. Now a specific case when we have B is equal to A, like we are finding the dot product of the same vectors A dot A. So what it will be? Magnitude of A into magnitude of A into cos 0, because theta is definitely 0, vector A and vector A. So what is the angle? Angle is definitely 0 degree. So what it will be? Cos 0 is 1. So the answer will be square of magnitude of A, or simply we can say magnitude of A will be equal to under root A dot A, vector A dot vector A. Now we have few rules, few observations. If vector A is 0 or vector B is 0, then definitely A dot B is equal to 0. If A and B are like vectors means in the same direction, then we have theta equal to 0. When we have two vectors in the same direction, then definitely angle between them is 0. And when angle is 0, so cos 0 is 1, we have just done. So A dot B will be equal to AB. Third observation is if A and B are unlike vectors. Unlike vectors means in the opposite direction. Like we have two vectors like this. Vector A and this is vector B. Right? So definitely the angle is pi. Angle is what? Pi. So cos pi is what? -1. So the result will be minus AB. And if A and B are orthogonal vectors means 90 degree, pi by 2. So when we have these type of vectors, so cos pi by 2 is 0. So definitely A dot B will be 0 in this case. Now next we have projection. What is projection? Projection is basically shadow, right? If we have OA vector, let's represent it with vector A, OB as vector B, and angle BOA. BOA, this angle is theta, right? And draw AM perpendicular on OB. Then OM is the projection of vector A on vector B, simply the shadow, right? And how we find the projection? We find the projection, this is the formula, A dot B upon magnitude of B. This is the formula for finding the projection of any vector on some other vector. So it is A dot B upon magnitude of B. Then next we have vector, or we call it as cross product. Let A and B be two non-zero, non-parallel vectors and let theta be the angle between them, right? And this theta is greater than 0 and less than pi. Then the vector product of A and B is defined like this. A cross B is equal to magnitude of A into magnitude of B into sine theta into unit vector n. What is this unit vector n? Unit vector n is a unit vector perpendicular to both A and B. Just because this is cross product, this is vector product, it means the resultant is going to be a vector quantity. If it is going to be a vector quantity, then definitely it will have some direction, right? So here we have to give that direction, which is vector, unit vector n. And vector A, B and unit vector n form a right-handed system. When a right-handed screw is rotated from A to B and it advances along unit vector n, then the system is called as right-handed. It is known as right hand thumb rule also. You must have done in your junior classes sometime. In a right-handed coordinate system, the thumb of the right hand points in the direction of the positive z-axis, when the figures are curled in the direction away from the positive x-axis towards the positive y-axis, somewhat like this. Then we get the resultant in the direction where our thumb is, thumb of right hand. And now again we have few observations. If vector A and B are parallel or collinear, when theta is equal to 0 or theta is equal to pi, then we have A cross B is equal to 0. And in particular, A cross A, when we have B equal to A, then definitely it is 0. If A is 0 or B is 0, then we define A cross B is also 0. For any vector A, we have A cross A. So by using this formula only, magnitude of A into magnitude of A into sine theta into unit vector n. Now this thing is going to be 0, right? And the entire thing is 0 then. Angle between these two vectors, let theta be any angle between A and B. Then A cross B is this AB sine theta unit vector n. And the magnitude of A is A and magnitude of B is B. We discussed earlier in this video only that sometime we write the magnitude like that, we represent it with the same variable. Now magnitude of A cross B will be AB sine theta. So from here only we can find out that angle between them sine theta will be equal to magnitude of A cross B upon AB, and theta will be equal to this thing. And unit vector perpendicular to given vectors, a unit vector n, which is perpendicular to both A and B, is given by this. This is the formula. Now vector product of an orthogonal vector trade for mutually perpendicular vectors like this: x-axis, y-axis and z-axis. All three axes are mutually perpendicular. Right now here we are talking about unit vectors I, j and k. We have I cross I, j cross j and k cross k, all are going to be 0. Why 0? Because definitely angle between them is 0. I cross j will be equal to k, right? I cross j, take the help of this circle, I cross j will be equal to k. But if we go in the opposite direction, we do it as minus j cross I, then also it is going to be k. Minus j cross I will be k. Now j cross k, j cross k. So if it is going in this direction, then definitely we will get the positive result, that is I. And when we go in the opposite direction from k to j, then we are going to get minus I, or we call it as minus k cross j. Same way here also. Vector product in terms of components. When two vectors are given in component form, then that's how we find A cross B, I cap, j cap, k cap. Now these scalar quantities A1, A2, A3, B1, B2, B3, and then we will find out. I hope you must have understood all these concepts, and now students, you can try the questions given in NCERT based on these concepts, and we are discussing all those questions in the online sessions also. So please be regular. Thank you very much for watching.